Okay, we're going to talk a little bit more about diverging and converging lenses. There are three types of images formed by, or two types really, but three types of images formed by thin lenses. There's um, real image, it's where DI is positive and the magnification is negative. All right. There is for converging lenses, when the object is closer to the lens than a focal length, you get a virtual image. Virtual image just means you have to look through the lens to see the image. You get a virtual image. The distance to the image is negative, which means it's behind the lens, and the magnification is then positive and greater than 1. This is what we use magnifying lenses for, to make things bigger, right? And then if you have a diverging lens, the focal length is negative. The image is always negative, virtual. The distance to the image is always negative, i.e. you have to look through the lens to see the image. You can't project it onto anything. The magnification is positive, but less than 1. Right? So this chart just kind of helps you figure out, all right, I've got um, converging lens, F is positive, but I'm farther away from the lens than a focal length, so I get a real image. It's positive, the magnification is negative. The image is real and on the opposite side of the lens from the object. Case 2, I have a converging lens, but now the object is closer than one focal length. I get a virtual image which is behind the lens. The distance to the image is negative because it's behind the lens, and my magnification is positive and greater than 1. And then finally, case 3, I've got a diverging lens. My focal length is negative. The image is always virtual. The distance to the image is always negative. I have to look through the lens to see the image. And the magnification is always positive, but less than 1. So this chart will help you sort out what's going on when you're looking at a particular lens. And that's it for thin lenses. Now we're going to turn to the eye and discuss the eye in the next video.